The battery wars are over, and China won decisively. Chinese manufacturers now control 55% of the global battery market, while Western competitors face systematic collapse despite billions in government subsidies and support. CATL alone commands 38% of worldwide electric vehicle battery installations. BYD reached 17% market share with 62% year-over-year growth. Meanwhile, Korean giant LG Energy Solution dropped to just 10% despite massive capacity expansion efforts. This isn't temporary market fluctuation. This represents fundamental technological leadership that reshapes the entire automotive industry. Welcome to Curiosity AI Podcast, Episode 21. Today we examine how Chinese battery manufacturers achieved unprecedented global dominance through systematic advantages that Western competitors cannot match. The numbers tell a story that challenges fundamental assumptions about technological competition and Western innovation leadership. Chinese companies don't just lead in market share. They've achieved superior performance specifications while maintaining cost advantages that make Western alternatives economically unviable. This transformation extends beyond automotive applications into energy storage, portable electronics, and grid infrastructure. Battery technology represents the foundation of electrification across multiple industries, making Chinese leadership particularly significant for global economic dynamics. We'll analyze the specific advantages enabling Chinese dominance, examine solid-state battery promises that may arrive too late to restore competitive balance, and assess investment implications for companies and consumers navigating this transformed market landscape. The data reveals systematic Chinese advantages in manufacturing excellence, supply chain control, and cost structures that compound over time. Understanding these dynamics becomes essential for investors, consumers, and policymakers as electrification accelerates globally. Today's analysis draws from independent testing institutions, financial performance data, and market research that confirms Chinese technological leadership rather than temporary competitive positioning. The scale of Chinese battery market control represents unprecedented concentration in modern manufacturing history. CATL's 38.1% global share exceeds any single company's previous dominance in battery manufacturing, while BYD's rapid growth to 17.3% demonstrates the depth of Chinese competitive strength. Combined Chinese market position represents approximately two-thirds of global production capacity, creating economies of scale that Western competitors cannot replicate, even with significant government support programs. This consolidation enables manufacturing efficiencies and cost reductions that compound competitive advantages over time. Korean manufacturers face declining relative positions despite aggressive investment strategies. LG Energy Solutions' drop to 10.7% share illustrates how even established players struggle against Chinese cost structures and technological advancement. Samsung SDI and SK On maintain even smaller positions while competing for remaining market segments. European and American manufacturers occupy marginal global positions, relying primarily on government protection rather than competitive advantages. Tesla's supplier diversification toward Chinese partners demonstrates how even premium Western brands recognize Chinese technological superiority. Market concentration statistics represent more than numerical shifts. Chinese dominance stems from systematic advantages, including government support, supply chain integration, and manufacturing excellence that create self-reinforcing competitive moats. Companies compete on performance and cost metrics that consistently favor Chinese manufacturers across all major application segments. The competitive dynamics suggest continued Chinese expansion rather than market equilibrium, as cost advantages enable aggressive pricing strategies while maintaining healthy profit margins for sustained growth investment. Chinese battery manufacturers achieve production costs of $40 to $60 per kilowatt-hour, while Western alternatives remain significantly higher, creating fundamental competitive moats that extend beyond temporary market conditions. These cost leadership positions derive from multiple sources beyond labor cost arbitrage. Chinese companies control critical material processing, including lithium refining, graphite production, and cathode manufacturing, eliminating supplier margins while ensuring consistent material quality and availability. Manufacturing efficiency comparisons reveal Chinese factories achieving higher yields and faster production rates than Western facilities. Automated production systems and process optimization contribute to cost advantages that scale with volume, creating self-reinforcing benefits as production capacity expands. Vertical integration enables Chinese manufacturers to capture value across entire supply chains rather than depending on external suppliers with separate profit requirements. This strategic positioning becomes particularly valuable during material price volatility or supply disruption periods. Raw material market dynamics shifted dramatically, with lithium costs falling 80% from 2022 peaks to approximately $30,000 per ton. While benefiting all manufacturers, Chinese companies maintain structural advantages through processing capabilities and supply chain relationships that Western competitors depend upon despite political tensions. Quality control analysis demonstrates Chinese manufacturers maintaining consistent performance across large production volumes, with minimal variation in capacity, resistance, and safety characteristics. This manufacturing maturity enables reliable mass production, quality meeting international automotive standards while preserving cost advantages. Investment capital continues flowing toward Chinese battery development at record levels, ensuring sustained technological advancement and capacity expansion that maintains competitive leadership over time. While Western companies promote solid-state batteries as technological leapfrogs, manufacturing realities suggest commercialization timelines that may arrive too late to restore competitive balance against advancing Chinese conventional technologies. QuantumScape's QSE-5 batteries demonstrate impressive energy density specifications at 844 watt-hours per liter, but manufacturing costs remain hundreds of dollars per kilowatt-hour compared to Chinese conventional alternatives achieving $40 to $60 production costs. The Cobra separator production process represents genuine innovation with 25 times faster heat treatment speeds than previous methods. However, scaling breakthrough processes to gigawatt-hour production levels requires additional development years and massive capital investment that may not justify economic returns. BMW's real-world solid-state testing validates practical viability while revealing automotive-specific challenges, including vibration tolerance, thermal management, and integration complexity, requiring engineering solutions before commercial deployment. Manufacturing equipment requirements differ substantially from conventional lithium-ion production, necessitating complete facility construction rather than production line upgrades. Capital intensity creates additional barriers for Western manufacturers already struggling with conventional battery competitiveness. Toyota's development timeline suggests commercial deployment beginning 2027-2028 in limited applications, with mass market adoption delayed until 2030 or beyond. Even optimistic projections provide Chinese manufacturers several additional years to advance conventional technologies while building market positions. Technical challenges persist, including dendrite formation, interface stability, and cycle life optimization, requiring continued research investment across multiple competing approaches with uncertain commercial outcomes. The fundamental question involves whether solid-state performance advantages justify development costs and timeline delays compared to rapidly improving Chinese conventional batteries that deliver excellent performance with proven manufacturing scalability. Independent testing institutions confirm Chinese battery technologies meet or exceed manufacturer performance claims across critical automotive metrics, validating technological leadership beyond marketing assertions. German TÜV laboratories validated CATL specifications through standardized automotive testing protocols, while Korean research facilities confirmed BYD charging performance under controlled conditions. These independent verifications eliminate manufacturer bias from performance evaluations. Temperature performance testing reveals dramatic Chinese advantages, with sodium-ion technology maintaining 90% capacity at -40 degrees Celsius, while conventional lithium-ion systems lose 30 to 50% capacity. Scandinavian facilities confirmed these results through extended Arctic exposure testing. Cycle life analysis demonstrates Chinese technologies significantly outlasting Western alternatives in accelerated testing protocols. CATL batteries exceeded 10,000 cycles, while BYD systems showed capability exceeding 1.2 million kilometers of vehicle operation. Charging consistency proves superior for Chinese batteries, with CATL and BYD maintaining rated speeds throughout charging sessions, while Western alternatives experience thermal throttling during extended fast charging, according to independent monitoring systems. Safety testing confirms Chinese claims regarding improved thermal stability and reduced fire risks through independent abuse testing protocols. Nail penetration and crush tests produced minimal thermal responses, validating manufacturer safety specifications. Manufacturing quality demonstrates consistent performance across large production batches, with European automotive testing institutes conducting comparative studies showing Chinese technologies achieving superior results while maintaining cost advantages. International certification processes confirm Chinese batteries meet global automotive requirements for commercial deployment, removing regulatory barriers to market adoption across major automotive markets. Financial markets increasingly recognize Chinese battery technology leadership through sustained stock performance and investment capital allocation toward leading Chinese manufacturers. Chinese companies report strong profit margins, while Western competitors require government subsidies for basic operational viability. This fundamental business model difference creates investment implications extending beyond cyclical market conditions toward structural competitive advantages. CATL and BYD provide direct investment exposure to fastest-growing battery technologies with established commercial success and expanding global market positions. Stock performance reflects market recognition of technological leadership and sustainable competitive advantages. Market timing suggests current periods offer optimal investment opportunities before Chinese dominance becomes universally recognized by mainstream financial analysts. Early positioning in leading companies provides maximum appreciation potential as competitive realities become apparent. Tesla's 4680 program achievements improve the company's battery competitiveness, but Chinese manufacturers maintain superior performance-to-cost ratios, according to independent analysis. Tesla investors should evaluate battery technology limitations when assessing long-term competitive positioning. Solid-state battery investments remain speculative despite technical progress, with commercial viability requiring several additional development years. Companies face execution risks while competing against rapidly advancing conventional technologies meeting current market requirements. Investment portfolio diversification should include exposure to Chinese battery technology leaders while maintaining positions in Western innovation companies for breakthrough potential. Geographic and technological diversification reduces concentration risk while capturing growth opportunities. The convergence of manufacturing excellence with cost leadership translates across multiple high-technology sectors, suggesting Chinese competitive advantages may extend beyond batteries into related electrification technologies. For consumers evaluating electric vehicle purchases, this analysis provides clear guidance based on comprehensive performance data and market trend analysis. Vehicles equipped with CATL batteries offer superior longevity and temperature performance specifications, while BYD technology provides fastest charging capabilities currently available in commercial applications. Chinese battery technologies generally deliver better value propositions than Western alternatives when comparing total cost of ownership, performance specifications, and expected service life based on independent testing validation. Tesla vehicles benefit from integrated design optimization and software advantages, but battery technology no longer provides competitive differentiation compared to Chinese alternatives. Consider Tesla for charging network access and software capabilities rather than pure battery performance. Upcoming sodium-ion vehicles launching in 2026 deserve consideration for budget-conscious buyers seeking advanced performance capabilities. Chinese technology enables dramatically lower purchase prices while providing excellent cold weather operation and extended service life. Solid-state battery vehicles remain several years away from mass market availability, with initial deployment limited to expensive premium models. Current promises exceed near-term delivery capabilities, requiring realistic expectations about commercialization timelines. Charging infrastructure compatibility increasingly favors Chinese battery technologies as global deployment expands beyond proprietary networks. Fast charging advantages provide practical benefits for daily usage patterns across diverse geographic regions. Vehicle leasing strategies protect against rapid technology advancement while enabling access to latest developments. 3-year terms avoid obsolescence risks during accelerated innovation periods while enabling upgrades as technologies become available. China's battery dominance extends beyond manufacturing into control of critical material processing and supply chain infrastructure that creates dependencies for Western manufacturers despite ongoing political tensions. Chinese companies process the majority of lithium refinement, graphite production, and cathode material manufacturing, controlling value creation across entire supply chains while reducing external dependencies for domestic manufacturers. Government policies significantly influence market evolution through trade restrictions, subsidies, and local content requirements favoring domestic manufacturers. U.S. tax credits require increasing percentages of materials from allied sources, while European regulations mandate sustainability compliance. Trade policy implications include potential export restrictions on critical materials and finished battery products. China's graphite export controls demonstrate leverage over global supply chains, while Western countries pursue diversification strategies struggling to match Chinese cost structures. Manufacturing capacity expansion targets exceed 6 terawatt-hours by 2030, with Chinese factories accounting for majority planned additions. This capacity growth establishes permanent structural advantages, while potentially creating temporary oversupply conditions. Vertical integration advantages increase as competition intensifies across the industry. Chinese control of mining operations, material processing, and finished manufacturing enables comprehensive value capture while reducing supply chain vulnerabilities. Regional market preferences influence adoption patterns, with Chinese manufacturers dominating Asian markets while expanding European and North American presence. Political considerations may temporarily protect domestic manufacturers, but technological advantages typically prevail over sustained periods. The battery industry transformation represents one of the most significant shifts in global industrial competitiveness achieved within a single decade. Chinese manufacturers have established comprehensive advantages in technology, manufacturing, cost structures, and market positioning that reshape automotive electrification dynamics. For consumers, the implications are largely positive through access to superior battery technology at competitive pricing, improved vehicle performance, and accelerated innovation cycles. Chinese technological leadership enables better products reaching markets faster than traditional development timelines. Investment implications favor early recognition of Chinese battery superiority before mainstream financial analysis reaches similar conclusions. Market positioning suggests optimal opportunities exist for investors seeking exposure to established technological leaders with sustainable competitive advantages. Strategic implications extend beyond automotive applications into energy storage, portable electronics, and grid infrastructure, where battery technology provides foundation advantages across multiple growing sectors. Chinese leadership compounds over time as market positions strengthen. Western manufacturers face challenging choices between accepting technological dependency or investing heavily in technologies that may struggle achieving commercial competitiveness. Government support provides temporary protection, but typically cannot overcome sustained technological and economic disadvantages. The battery wars demonstrate how rapidly global industrial leadership shifts when companies achieve breakthrough manufacturing capabilities combined with cost advantages and systematic government support. This competitive pattern may repeat across other high-technology industries as global dynamics continue evolving. For policymakers, Chinese battery dominance illustrates the importance of sustained industrial policy, research investment, and manufacturing excellence in maintaining technological competitiveness. Short-term considerations often conflict with long-term strategic requirements for industrial leadership. The evidence strongly suggests Chinese manufacturers have achieved sustainable advantages across critical performance dimensions, positioning them for continued market leadership as global electrification accelerates across multiple application sectors. Thanks for joining us on episode 21 of Curiosity AI Podcast. If this analysis of global battery competition and technological leadership engaged your interest, subscribe for continued examination of industrial transformations reshaping economic competitiveness. Until next time, remember that technological leadership creates compounding advantages that determine which countries and companies will control the infrastructure of future economic development.